Hello everyone. Problem of the day question was strings rotations of each other. We are given two strings S1 and S2 of equal lengths. The task is to check if S2 is a rotated version of the string S1. Note, a string is a rotation of another if it can be found by moving characters from the start to the end, or vice versa, without rearranging them. Understanding the string rotation problem. Let me explain this string rotation problem and the elegant solution we have for it. The problem in simple terms. We have two strings of equal length and we need to check if one is a rotation of the other. What do we mean by rotation? Think of a string like a circle. The rotation means taking some characters from one end and moving them to the other end, keeping all characters in the same order. Real world analogy. Imagine you have a string of beads, red, blue, green, yellow. If I rotate it by moving two beads from the start to the end, original was red, blue, green, yellow. After rotation two beads, it will be green, yellow, red, blue. The beads are in the same order, just starting from a different position. Why the naive approach doesn't work well? Yes, first thought may be, let's try all possible rotations and compare. But that's inefficient. We would have to rotate 10 times, where n is string length. Each rotation may take O of n time. Totally O of n squared time complexity, which is too slow. The clever insight. Let's think about our bead example again. If I take the original string and duplicate it, red, blue, green, yellow plus red, blue, green, yellow equals red, blue, green, yellow, red, blue, green, yellow. Now look at our rotated version. Green, yellow, red, blue. Notice green, yellow, red, blue appears in the middle of our duplicated string. Why this solution is efficient? Time complexity is O of n. Concatenating S1 with itself. O is O of n. Checking substring using includes typically O of n with modern algorithms. Space complexity is O of n. We create a new string of length 2. Compare this to the naive O of n square approach. Visualizing the process. Imagine you have a circular track with letters A, B, C, D. If you duplicate it, you get A, B, C, D, A, B, C, D. Any rotation just means starting at a different point on the circular track. And our duplicated string gives us all possible starting points in a linear format. Here is the solution code. Let me complete. Compilation completed. Case 1 is successful. Here is the quick check. Different lengths means no rotation possible. Here the magic happens. Duplicate S1. Here check if S2 appears as a substring. Common misunderstandings. But what if S2 appears by coincidence in time? This can't appear because if S2 appears in S1 plus S1, it must be a valid rotation. What about circular strings? That's exactly what we are simulating. A string rotation is like a circular string. Does this work with all rotations? Yes, all rotations from 1 to n-1 are covered. Takeaway. The key insight is when dealing with rotations or circular structures, sometimes duplicating the data gives us a linear view of all possibilities. This pattern appears in many problems. Circular buffers, rotated arrays, pattern matching in circular sequences. So remember when you hear rotation, think duplicate and check substring. Let me submit the code. Problem solved successfully. My current streak is 381 days. Put your TK in the comments below. Let me push the code to the GitHub. Message after commit is add solution for checking if two strings are rotations of each other with examples and complexity analysis. Let me commit and push. The code is pushed to the GitHub. You can grab the code link in the description. Thank you for watching this video. Like and subscribe to Newscraft Studio for more awesome content.